That is primary structure, secondary structure, tertiary structure, and quaternary structure. Okay. Now here, here we are going to discuss primary structure of proteins, that is polypeptides. So what actually primary structure of protein? Primary structure means the study of the covalent bond present in the molecule. Okay, and the secondary structure and tertiary structure and quaternary structure includes the study of weak forces like van der Waals force interactions, hydrogen bonds, and ionic interactions. So we are taking here the primary structure of protein or a polypeptide first. Okay. So what is the primary structure of protein? As I already told you that the primary structure means a study of the covalent bonds. Now we know that the protein is a polypeptide. And what are polypeptides? Polypeptides are the polymers of amino acids. So the repeating units in the protein molecule or the polypeptide molecule is amino acids. Okay, and these amino acids are linked by a bond that is called amide bond or amide linkage, which I have discussed already in the previous lectures. Now today we are going to discuss the primary structure of the protein, that means the covalent bonds, study of the covalent bonds. Now as we know, the protein molecule or the polypeptide molecule is made up of amino acids. So actually we are going to study the amino acids. What are the amino acids present into a particular protein or the polypeptide chain, that is called primary structure of a protein. So what actually primary structure of protein? That is the study of the sequence of amino acids in a particular protein or polypeptide chain. In a particular protein or polypeptide chain, what is the sequence of the amino acids? In what sequence these amino acids are present into that particular protein or polypeptide chain? And this amino acid sequence determination is done by end group analysis. Now what is end group analysis or what is end group? So by convention or by the rule, the free for in a polypeptide, I have written a tripeptide here. Okay, so we will start writing the protein molecule from the left hand side, and from the left hand side we will write free NH2 group of a molecule, and that amino acid is number 1. Always that amino acid is given number 1, and which has free amino group and which will be written as left hand side, and that is called N-terminal amino acid. Here this amino acid is called N-terminal amino acid because here this is the NH2 group is free and written as left hand side. So left hand side, and this is number as 1. Okay, and at the C terminal, what is C terminal? That is written as right hand side. So C terminal means where the amino acid ends. In a polypeptide chain, where the amino acid present, last amino acid is present, either at the left hand side or at the right hand side. At the left hand side, we write free NH2 group, and this amino acid is called named 1 or numbered 1, and the right hand side and amino acid is given the name C terminal, which have free COOH group. So here in this tripeptide molecule, this amino acid is N-terminal amino acid, and this amino acid is C-terminal amino acid because it has free COH group. That's why it is called C-terminal, and written as right hand side. Here this amino acid has free NH2 group and written as left hand side. That's why it has free NH2 group. That's why it is called N-terminal amino acid. So in a peptide chain, in a protein chain, we sequence the amino acid. We find out the position of particular amino acids by end group analysis, means at the end which amino acid is present. Okay, so by end group analysis we analyze the whole sequence of the amino acids. So we will take all these cases one by one. So we have two methods for end group analysis. And these methods are based on the terminals or based on the terminus. We have one C terminus and we have another N terminus. So first of all, we will sequence, we will determine, we will position, we will identify the amino acids from left hand side, that is N terminal end, which have free NH2 group. So it is called N terminus identification. And for N terminus identification, we have the first method that is called Sanger's method. Now what is Sanger's method? In Sanger's method, we take this reagent that is called Sanger's reagent, which is 2,4-dinitrosorobenzene. So 2,4-dinitrosorobenzene, D and FB, are known as Sanger's reagent. When this Sanger's reagent is treated with a polypeptide chain, or a polypeptide means a protein. So from now here, this is an N-terminal identification, means this 2,4-dinitrosorobenzene will react with NH2, that is free NH2 group, that is N-terminus. This F-fluorine and this react with this NH2 group of this polypeptide chain under alkaline medium. The medium is alkaline, and here HF will release H from here, and this 2,4-dinitrosorobenzene is bind with this amino acid, this N-terminal amino acid, and we have this is called labeled peptide. Now we have, this is a peptide chain. This is a peptide chain, and we have labeled this peptide chain from N-terminus to the 2,4-dinitrosorobenzene, or we have included 2,4-dinitrophenyl group here. This is 2,4-dinitrophenyl group. So this is 2,4-dinitrophenyl, and this is amino acid. So this is labeled peptide. Now this peptide chain is labeled. Now what will we do? Now we will cleave the amide linkage. We will hydrolyze this amide, this peptide, this protein molecule. So when this labeled peptide is heated with dilute HCl, that is hydrolyzed under acidic conditions, what will happen? All the peptide bonds will cleave. So one cleavage is from there, one cleavage is from, and so on. I have from this the dotted line, because there will be a further chain of amino acids. So now this peptide chain will cleave through hydrolysis. So this CO will convert it into COOH, and this amino acid, this is the first number amino acid, this is the first N-terminal amino acid, this is the N-terminal amino acid, this is the N-terminal amino acid, which is combined with this 2,4-dinitrophenyl ring. And rest of the amino acid will be into the solution. So we will have a mixture of amino acids into the solution. This is one amino acid, this is another amino acid, and so on. So we will have a mixture of amino acids into the solution. So this labeled amino acid is separated by electrophoresis. You know the electrophoresis technique. This is separated by electrophoresis and identified by migration values, or identified by migration values as compared with the standard DNP, this is 2,4-dinitrophenyl amino acid value, or they can be identified by mass spectrometry. Okay, we will separate out this, and we will take mass spectrum of this molecule, and in mass spectrum the m by z value, this is m+1p, will give the molecular mass of this particular molecule. Okay, so this can be separated out and can be identified either by measuring the migration values of this molecule under electrophoresis, or may be identified by mass spectrometry. Okay, so by identification of this amino acid, we can identify what is the N-terminal of this protein molecule. Which amino acid is present at N-terminus, this is identified. Now, what is the weakness of this method? Actually, this method can be applied only once. Because once this peptide is labeled, and when we hydrolyze it, the peptide chain will cleave. So we can identify, we can apply this method only once, because after that the peptide chain will cleave. Okay? Now what is the second method of identifying the N-terminal amino acid? The second method is densyl chloride method. Now what is densyl chloride? Actually this reagent is known as densyl chloride. What is this reagent? It is 1-dimethyl. This is the first position of naphthalene ring. So this is 1-dimethyl amino, NMe2. Dimethyl amino, this is NMe2, dimethyl amino naphthalene, because this is the first position of naphthalene, that's why this is 1-dimethyl amino naphthalene, and this is the fifth position, 5-sulfonyl chloride. So 1-dimethyl amino naphthalene 5-sulfonyl chloride is called densyl chloride. So this reagent is known as densyl reagent or densyl chloride. When this densyl chloride is treated with this, with a polypeptide or a protein molecule, what will happen? This will react from the N-terminal side. This is the NS2, free NS2 from N-terminals, and it will react with this Cl molecule. And HCl will relieve the system, and the reaction is occurring in alkaline conditions, in the presence of base, and we have this labeled polypeptide chain. This is called densyl polypeptide chain. This polypeptide chain is labeled from N-terminus through with the densyl chloride or by the densyl chloride. After that, we will again hydrolyze the chain. We will hydrolyze it. So once this will hydrolyze from the amide bond, it will break. All the amide bonds will break under sp condition, and we will have what? This densyl amino acid. This is the densyl reagent. This is called densyl amino acid. And plus a mixture of free amino acid. We will have a mixture of free amino acid into the solution. Now, this molecule is fluorescent in nature. It has fluorescence. So due to the fluorescent nature of this molecule, it can be easily identified through chromatography. So this molecule, being fluorescent, can be easily identified by chromatography, and by identifying this molecule, we can identify what is the N-terminal amino acid of this polypeptide chain. But again, what is the weakness of this method? What is the disadvantage of this method? The disadvantage of this method, like the first one, that is Sanger's method, this method can also be applied only once. Because after labeling one time, this peptide chain is going to be cleaved. Another method for N-terminal analysis is advanced integration method. Now, advanced integration method is a very important method. In this method, we take phenyl isothiocyanate (PIEC) as a reagent, and this phenyl isothiocyanate (PITC) is treated with polypeptide. Now the amino acid CNS2, which is present at the free amino acid N-terminal level, will react with this phenyl isothiocyanate. And how to react? Actually, this NS2 is a molecular electron can act as a nucleophile, and this C-N will towards nitrogen, and this N will get attack on this carbon atom. And the reaction is performed under alkaline conditions, and after attacking this carbon, what is the product is the phenyl NH, and negative is converted, and negative, there is the negative charge, but after when this NH2 will attack over here, this NH2 will convert into NH2 positive ion. It will get a positive charge here, and that NH2 positive will release one H plus, and that H plus is coming here. That N minus is converted into NH. This is NH. Single bond C, double bond S is the double bond S, and now this NH is from this NH2 molecule. After taking on that carbon, it will convert into the NH2 positive ion, and this NH2 positive release one H plus ion, then convert into NH, and this is the remaining polypeptide chain. Okay. Now this molecule is called phenyl thiocarbamyl peptide. This is called phenyl thiocarbamyl peptide. PIC, phenyl P, thio T, carbamyl C, peptide or polypeptide. Okay. Now this molecule is treated with anhydrous trifluoroacetic acid. When this molecule is treated with anhydrous trifluoroacetic acid, what will happen? This molecule will undergo cyclization. And the course of cyclization is like that, with the 6-member ring, 5-member ring is shown here. This amide bond will cleave from here. This is the amide bond of first amino acid. It will like that. It will like there. And this C positive, on this C positive ion, this S minus will attack here. And simultaneously this NH bond is on here. So what will be the product? See? PH, this is the phenyl group. NH, this is the NH2. This NH is linked with this C. This is the carbon. This is the carbon. Now C double bond H is converted to C single bond S. This is C single bond S. And this S is attached to C double bond O. This S is attached to C double bond O. Okay. Now this is clipped from here. So the chain is goes out. So C double bond O. C double bond O. CHR1. This is CHR1. And this is N. This is N. And double bond. CNH. Double bond C. Double bond C. And after, when this double bond is, this bond will come here, this electron will come here, this time will carry a positive charge, and after getting positive charge, this S plus bond is released from the histone. And the rest of the peptide chain is, this is the rest of the peptide chain, NS, and under acidic condition it will completely coordinated, it will be converted into C positive, CHR2, CO, NH, CHR3, CO. This is the rest of the polypeptide chain. That's why I am here at the dotted line. Okay. So this remaining polypeptide chain, which have one amino acid less than the original polypeptide chain. Okay. And that which amino acid is cleaved from here? That is the N-terminal amino acid. So this remaining polypeptide chain having one amino acid less than the original polypeptide chain from N-terminal site. So this remaining polypeptide chain can undergo further advanced degradation from this N-terminal site. So this is the advantage of this method. Here the polypeptide chain, both polypeptide chain is not cleaving. Only the N-terminal amino acid is detached from this polypeptide chain, and remaining the amino acids are there. So this polypeptide chain can undergo further advanced degradation or further treated with this phenyl acid. So stepwise we can analyze one by one the amino acids from whole polypeptide chain. Now this molecule, which is thiazolinone derivative of the N-terminal amino acid, in under acidic condition further undergo rearrangement. And further undergo rearrangement reaction and will convert into phenyl thiohydroxyl derivative. This is the phenyl thiohydroxyl. This molecule is called phenyl thiohydroxyl. If there is H, this is called phenyl thiohydroxyl. Now we have here R1. This is the side chain of first amino acid. That's why this is phenyl thiohydrogen derivative of the amino acid. See, this part of this phenyl thiohydrogen derivative is coming from phenyl isothiocyanate. And the remaining molecule, that is CO, CHR1, NH2. This is COH, this is NH2, and CH. This is the side chain of the amino acid. So after identifying this phenyl thiohydrogen derivative, we can easily identify what is the N-terminal amino acid. And what is the advantage of this method? The advantage of this method is that the remaining polypeptide chain can undergo further enzyme duplication, and one by one we can identify the amino acids from N-terminal side, which amino acid and what is the position of amino acids over there. Okay, so this is all about N-terminal integral analysis from N-terminal side. Now another side is C-terminal side. Okay, so the C-terminal side is a C-terminal analysis. So the only method available for C-terminal analysis is carboxypepdidase method. So this is not actually a chemical method. This is not actually a chemical method. This is an enzymatic method. We will do enzymatic cleavage of the polypeptide chain from C-terminal side. So what is this enzyme? This carboxypepdidase enzyme is an enzyme of pancreas. This enzyme is released by an organ, that is pancreas. Okay? Now what it do? This enzyme, we know that enzymes are highly selective in their action. So this carboxypepdidase enzyme, which is released by the pancreas, this is selectively hydrolyze the peptide bond at C-terminal. That is, it will cleave the bond C-terminal amino acid. It will release the C-terminal amino acid. It will free the C-terminal amino acid by cleaving this amide bond. So suppose this is a polypeptide chain. So I have written free COH group here. That's why I have written this N-terminal side as a dotted line. Okay. So this is a free C-terminal end having a free COH group. What this carboxypeptidase enzyme will do? This carboxypeptidase enzyme will selectively hydrolyze this. This is the C-terminal side. This is the terminus. This is the end where it's free COH group present. But this is the C-terminal side. Written as right hand side. This amide bond will cleave, and this amino acid will become free. So when this amino acid becomes free, we can easily identify that amino acid. This is the NH2CHR3COH, which is free from here, and remaining polypeptide chain will increase. So by using this method, we can selectively cleave the polypeptide chain from C-terminal side, and one by one we can identify what is the position of the amino acid or what is the sequence of the amino acid in the polypeptide chain. Okay. Now this is a C-terminal. Besides these methods, which are N-terminal methods and C-terminal methods, we have some more methods. We have some more chemicals which selectively cleave the peptide bond or peptide linkage. These are called peptide cutters. Okay. So what are these? First enzyme is trypsin enzyme. PSIN is the trypsin. What trypsin do? This will cleave the peptide bond at C-terminal 2. The C-terminal 2 where arginine, lysine is present. What does it mean? If suppose this is a polypeptide chain. Okay? And suppose here this is the arginine molecule, or suppose it is a lysine molecule. So suppose this is arginine molecule, or suppose this is a lysine molecule. If we treat this polypeptide chain with this trypsin molecule, what will it do? It will cleave this amide bond from C-terminal side. Now what is C-terminal side? Because every amino acid has two sides, N-terminal side and C-terminal side. See, this molecule, this is the amino acid. It has two sides. This is the side chain R2, this is carbon in which hydrogen is attached, and this is where this is NS. This is called N-terminal side, where COH group. This is called C-terminal side. So this is the amino acid molecule, and from both sides we have amide bonds. This is one amide bond, this is another amide bond. So which amide bond it will cleave? It will cleave the amide bond. It will cleave the amide bond from C-terminal side, means this side, right hand side. It will cleave this amide bond. This C-terminal. Of where? If this is arginine or this is lysine molecule, but what is the condition? But not if next to proline. But not if next to proline. Suppose this molecule is proline. Suppose this amino acid is proline, and this is arginine or lysine. And if you treat this molecule with trypsin, it will not treat this amino acid. So it will cleave only arginine and lysine C-terminal amide bond when it is not present to the next to the proline molecule. If it is present next to the proline molecule, then it will not carry. Okay. Second enzyme is chymotrypsin. This is again it will cleave the peptide bond C-terminal to phenylalanine and tyrosine. Phenylalanine and tyrosine. So, if this is phenylalanine or if this is tyrosine, then it will cleave the C-terminal side peptide bond. But what is the condition? If it is not next to proline, if this molecule is proline, then this will not happen. Next enzyme is elastase enzyme. Elastase, E-L-A-S-T-A-S-E, what elastase do? This will again cleave the peptide bonds from C-terminal side, suppose this is amino acid, this is C-terminal side, this is the N-terminal side. So it will cleave the peptide bond from C-terminal side of alanine, glycine, serine, valine. Alanine, glycine, serine and valine. If this molecule is either alanine or glycine or serine or valine, then this is cleaved by elastase enzyme from the C-terminal side, but not if next to proline. But if it is proline, then this is not going to happen. Next enzyme is thermolysin. It will cleave the peptide bond of isoleucine, methionine, phenylalanine, trypsin. Sorry, not trypsin. This is tryptophan. This is tryptophan, tyrosine and valine from N-terminal side. Means if this molecule is isoleucine or methionine or phenylalanine or tryptophan or tyrosine or valine, then it will cleave the peptide bond from N-terminal side, from here, not from C-terminal side. It will cleave this peptide bond from this N-terminal side, from the left hand side. Remember it. Okay? But again the condition is that if this molecule is, but if this is next to the proline, then this is not going to be happening. Okay? Now the next enzyme is pepsin. This is again cleave the peptide bond from the N-terminal side, from the N-terminal, not C-terminal, from the N-terminal side of leucine, phenylalanine, tryptophan and tyrosine. Leucine, phenylalanine, tryptophan and tyrosine. But again the condition is same. If this molecule, if this leucine, phenylalanine, tryptophan and tyrosine is next to this proline molecule, then this enzyme will not cleave these amino acids. Okay? And the next enzyme is endopeptidase V8. Endopeptidase V8, and it cleaves the C-terminal side of glutamic acid. If this is the glutamic acid molecule, then it will cleave this peptide bond from C-terminal side. This is the endopeptidase V8. Besides these enzymes, we have some chemicals which also cleave the peptide bond selectively, selective site. One such chemical is cyanogen bromide, CNBr. Now what this CNBr do? This cyanogen bromide, this is CNBr, selectively cleave the C-terminal side of methionine. If a methionine molecule is present at anywhere into the polypeptide chain, it will cleave that polypeptide chain from C-terminal side. See, suppose this is a polypeptide chain, and suppose here this is a methionine molecule is present. So it will, this cyanogen bromide, what will cyanogen bromide do? This is the C-terminal side and this is the N-terminal side of this methionine molecule. It will cleave the C-terminal side or C-terminal amide bond of this methionine molecule. So this is selectively for methionine. Another is, this is called a hydrogenolysis, that is treatment with hydrazine, NH2, that is hydrazine. So when we treat this polypeptide chain to hydrazine, it will selectively cleave the C-terminal side, and the C-terminal amino acid will be free. But what is the disadvantage of this hydrogenolysis? Actually, this hydrogenolysis will give a number of side products or number of undesired chemical reactions. So this hydrogenolysis, so by applying this hydrogenolysis, we can apply only once this hydrogenolysis method, because we cannot use this method again and again like carboxypepdidase, because these will give undesired chemical reactions. So many chemical products will be there. So the hydrogenolysis will be applied only where the carboxylase, this carboxypepdidase method is not applied.